Hello, and welcome back to Satisfactory Outposts in the Desert. In the last episode, I used an example of why it is critically important to spend at least a few minutes planning out your layouts before placing them, especially if you're recording for YouTube. So I hope that was instructional. Uh, After the episode ended, I did as I said, and I just moved these belts. I switched the belts that I was using. It makes a lot more sense if we use all of the belts on the southern side here. And making that swap, I was able to improve the design quite a bit. Now, if you can see, the iron plates are on the lowest belt, and that means we don't need to use conveyor lifts here to input them because they're always within reach of all of the assemblers, and we just bring down the top belt of screws for the last cluster, and we can belt it again without the conveyor lifts. Also on the inside, I raised it off the ground, and we eliminated the need for the conveyor lifts on the inside. It looks a lot cleaner, and I was kind of struggling with whether this was acceptable or not. The belts clipping with the mergers, and then I realized I'd just been like blocking it out of my memory. But whenever you have any manifold system or like on stackable poles or any bus, the belts always clip with the mergers and the splitters. So yeah, of course it's fine. Now setting up for the last part of this, the iron outpost, the modular frames, we're just going to bring this is a belt of reinforced iron plates that we're producing here. We're bringing it straight over to the north to an array of 20 assemblers that will be making the modular frames using the alternate recipe for alternate bolted frames. We should set all of these up. And over here I decided, just for a little variety, we'll use the double manifold system where the inputs are facing each other instead of the outputs as before on the bolted iron plates. I think this also makes more sense when you're working with the 4 belts of screws that we need. It should produce a design that's a little cleaner. If done correctly. Alright, so all the recipes are set. We'll have the iron plates, reinforced iron plates. I think we're going to have them on the ground level. And then we'll have 4 stacks of screws above them. So we'll put a splitter. And we're going to, are these not aligned? That would be a kick in the teeth, wouldn't it? No, they are. Okay. So we're going to align the splitter with the first input. It's just weird that I'm not getting the alignment for the machine behind me, but okay, there we go. It was just the orientation. Now we make sure, that it's perfectly aligned with our conveyor poles. Let's put all of our splitters down first. Not crazy about that, but we can change that if we have to. Okay. Let's take a look at this one. Yeah, let's just... Is this... Yeah, okay, that's straight. So let's just move the conveyor poles back a little bit. 3, 4. Okay. These will all be fed with reinforced iron plates. And we're going to continue this out because we want to collect the excess, the unused reinforced iron plates in a storage container. We're making 180 per minute. This array of assemblers will only consume 150 per minute. Next we have 4 lines of screws, 4 belts of screws. And I believe we'll have a slight excess of screws, but we'll have to collect them at the end again. So just to make sure that we're aligned, we actually need, should we go up or down? Yeah, we're gonna have to go above. Let's see the best way to do this without clipping. Good so far. Alright. Can we use this belt without any clipping? Yeah, we can. Nice. Okay. So that's 6 high. No, it's 6 high because we need to go over this belt of ingots here. And now they can all come down. Excellent. Now, if we've done this correctly, we should be able to avoid the use of any conveyor lifts to feed our assemblers. Let's just check. So you can stack them directly on top of each other, aligned with the second out or input for the assemblers. Just watch your splitter. Do you see how when I place the first one, my cursor automatically moved up to the second belt, but for some reason, the orientation flopped. Like you need the input to be coming from, the actual direction that the items are flowing. Now the top level is always the harder one, and there we go. These require 140 screws per minute, that's a Mark III belt. Require 7.5 reinforced iron plates per minute, that can we use a Mark I belt for that. So on this side, we'll draw from the top belt, and on the western side here, we'll draw from the lower belt of screws. And then these belts will travel down here. The third and fourth belts, these will be unused for the first two clusters of 5 assemblers. And once we get to this point, we'll just bring them down and repeat the process. All right. So each of these belts has 750 screws per minute on them. And each of these clusters, or is it 750? Yeah, 750 screws per minute. Each of these clusters will require, I think it's 700. 140 times 5. Yeah, 700. So there'll be an unused 50 screws per minute on each belt. And that may be worth collecting into a storage container. Why are these screws? Oh, that's weird. Need some height. Oh, I see what happened. There we go. Alright, now let's quickly add our splitters. Just trying to get them as lined as possible because we don't have a lot of extra space. Now, in order to make this work without using conveyor belts, you need to find the right spacing between your bus here in the center and the assemblers. If I had been even one space closer, the belts would have been too steep for this third belt. So just play around with it until you find the correct spacing. And always watch the orientation for your splitters, because for some reason they occasionally will swap their direction, and the mechanism for that is unclear. Now let's do our upper belts with the Mark III belts, all going into the second input. Actually, we should probably do the upper input first, because if there's a problem with alignment, it's going to be on this upper belt. Looking good. So close. So close. Okay. Now we'll do the middle belt with the lower belt of screws. This kind of arrangement with the outputs facing each other, the inputs facing each other, rather, is sometimes called a double manifold if you're drawing from the splitter on both sides. You know, like our reinforced iron belts are feeding on both sides. So if you see or hear anyone talking about a double manifold system, this is what they mean. And usually when the machines are just drawing from a bus like this from one side, that would be a single manifold. We're using Mark 1 belts for the reinforced iron plates because they only need 7.5 units per minute. Mark 1 belts, fewer resources. Alright, let's get some power up here. Let's calculate how many we actually can power. They all require 50 screws per minute, 56 screws, and we can only move 240 right now. So you just divide 240 by 56. You get 4.2. So we'll power 4 of them. We'll power 1 assembler from each of our 4 clusters. That sounds good. Let's find some power. Let's bring this over. This is the center. We'll put it here. And let's just upgrade this to a Mark II, just because. And then we'll put a standard power pole between each assembler. Alright. And we'll power I guess we'll power the first 2 in each cluster, coming from the south, the direction the resources are flowing. Alright. Let's set up our outputs. Outputting to the north. And we'll have to do the same thing for the other half of the assemblers. Oh no! At some point I removed a foundation there, apparently. I'm a little curious how we're doing on power. It's climbing. It's definitely climbing. But I think we'll probably have enough to get through our limestone to concrete outpost, and then we'll need to revisit our coal smelters. Or coal generators, rather. Alright, outputting to the north. Using splitters here, these should be mergers. Merger, okay. Good. Alright. Now the question, do we want to collect our excess screws? Do we need them? That is the question. I seem to remember computers requiring screws with one recipe that I'd never used. I would always use an alternate recipe. I'm just going to check on that really quickly. Let's see. Screws used to make computers, yeah. But there are alternate recipes that do not require screws that we will absolutely be using. Still, you know, let's not waste them. Let's try to collect these screws, these excess screws. It'll be 50 each belt, so it's an extra 200 screws per minute. You know, it's not nothing. And we're also collecting these iron plates. So what's the best way to do this? We'll have I guess we could use Mark 1 belts for these outputs. Let's think about it while we set up these outputs. Each assembler is producing 5 per minute, so each side is 50 per minute. So we can use Mark 1 belts for each side, and we'll need to use at least a Mark 2. We'll use a Mark 3 belt to merge each, each side of these 10 assemblers together. But the real question is how to route these resources to basically this area right here where we've got that industrial storage container. That's where we'll set up, a collection of storage containers to collect all of the components, the parts that we've made in this outpost. There's another missing foundation. It's just an accident waiting to happen. I was playing a multiplayer game and someone had the amusing idea that there should be like an LED counter near the hub that says like days without an accident, and each time you take damage it's reset to 0. So from this area alone, we need to collect 1 belt of reinforced iron plates, it's 30 per minute, 1 belt of modular frames, producing, what is it, 5 times 20, so 100 per minute, 1 belt of screws. A Mark III belt can handle all 200 screws per minute. So reinforced iron plates, modular frames, and screws. That's only 3 belts. But we have to merge all 4 belts of screws onto a single belt. Okay, so let's bring this out. Maybe we should deal with this first. I think the first step is going to be getting those reinforced iron plates off the ground. And then I wonder if we can just do like something like this. And that belt shape is not going to work, but maybe once we make the turn. Right, there'll be a turn here. All right. Yeah, that's good. So we'll put a merger here. Merger outputting this way. Try to line it up with everything. And this belt, this can be a Mark 1 here. This Mark 1 belt into the merger. It's going to be a Mark 1 also. Just carrying 50 frames per minute into the merger. I guess this could be a Mark 1 here. Just got a, 30 frames, or 30 reinforced iron plates per minute. Just in the name of, like, absolute efficiency. This has 50 screws per minute, and we're going to be merging it with another belt of 50 screws per minute. What's the best way to do that? And just to make it look the best, to square it off. Is that too close? Oh, yeah, my bad. One space too close. Yeah. Okay, that's not bad. And we'll put a merger on the belt right here. Okay, pretty good. So now this belt has 100 screws per minute. And we'll just drag everything. It's the best way. Like, I would like to, I think we just need to stay on the outside. And we'll bring the 2 belts of screws right here. What's the best place to merge them? I mean, obviously, the sooner you merge them, the fewer belts you need. Should we merge up or down? This is on the second. We should merge up. Okay. Just making this up as I go, so it may take a few tries to make this look perfect. Or as perfect as it needs to. I don't think we can, it would be too steep. Let's see if we can move it out a little bit. And go up. Too steep. There we go. And no clipping. So it'd be right here. Merger, not a splitter. That's super close. Yeah, I need to bring it out more. But that general idea will work. The only issue is potentially the clip-in with this belt. This is probably the best way to handle that. Do the turn first, and then the raise, the lift. I don't know how many spaces you need for the lift. I think it's 4, maybe? 1, 2, 3, 4. Alright, nice. Okay. So now this belt is being fed by 2 belts of 50 screws per minute. And what we're going to do is we're just going to actually, that's what I really want to do. Just to keep it as clean as possible. Is that level? Nice. 1, 2, 3, 4, 5. Just counting the foundations for the length that this belt can be. And then we'll put another merger right here. Iron rods. Oh man, we're really running low on many resources here. We're almost out of concrete too. Did we not power these up? Well, that was an oversight. Fortunately, we've got a... Ugh. Okay, I'm gonna have to get super ghetto here. Just briefly. Can't make a craft bench because we don't have the iron rods. Okay. I will replace those momentarily. Craft bench. Picking up iron ingots from the belt. Handcrafting them into iron rods. Okay. Replacing our conveyor poles. Adding a power line. I think we can support all 4 of these machines, no problem. Now we're producing rods. Yeah. Okay, great. Do you think that there's a chance that concrete's an issue? It's absolutely going to be an issue. Merger. And done. So now we've got... Why aren't there any modular frames? Did we... Okay, missing screws? It shouldn't be missing screws. Huh, strange. There's no screws traveling down these belts. Why is that? Oh man. Because for some reason the belts aren't actually passing through the splitters. they're just clipping right through them, but they're not connected. We've seen that before. It's annoying. I hope they correct that. Alright. Now things are working. Let's just quickly check to make sure. Yep. No screws here. Okay. So we've got screws on the belts. Let's just make sure that there are screws on the other side as well. Yeah, all those belts have screws. Okay, good. Now, to get these belts over here, let's set up our storage containers. We've also got one extra belt here of iron plates that's not being fully used. It's right here. So we'll make this iron plate belt our first. Then we'll need a belt for screws, or a storage container for screws, for reinforced iron plates, modular frames, and then this will be belts, or plates rather. Alright. So we clearly don't have enough concrete to bring these belts over. Tempted. Yeah, it's probably the best. For now, this is ghetto, but I am going to just borrow the concrete. It's too much. Let's just borrow this concrete. And that should get the job done. I was thinking about using attachments on the wall, but if we routed it along the wall, then we just have to come back off the wall here to feed our storage containers. So I think we'll just use stack conveyor poles. This will be the storage container for the iron plates. Let's just move this slightly. So that we can sneak under there. You know, generally using the wall is better because it's not taking up ground space where you're running. But in this case, I just don't think it's going to produce a really clean look. This is 2 up. And now this will come down to go under. Guess we could leave it up a little bit longer. not crazy about it, but actually I wonder if we can. Of course we can. That's the way to do it. If it's long enough. Let's at least, try to align it here. Nice. Yeah, that'll be a lot better. We don't have this dumb zigzag going on. Okay, better. Let's grab some rods while we're here. Okay, so we've got 3 belts, screws, reinforced plates, modular frames. I want to get these modular frames off the floor pretty quickly, so I think we'll do that right here. 1, 2, 3. Just shift everything up. No, I could be using reinforced, or just iron plates, Mark 1 belts for the lower 2 belts, but just to get this done quickly, we'll stick with Mark 3s. 1, 2, 3, 4, and 5. Actually, this is a good question. Should we turn it here? Should we turn it here? If we turn it here, that might be too close. Okay, so we'll turn it back here. We'll replace some of this glass. Borrow from here. Extremely ghetto, but we can replace that as soon as we visit our starter factory again. Here we go. One, two, three, four, 5. Okay. So right here, between these 2 storage containers, just take this down. That's going to be clipping. Okay. There are a lot of things that I'm not crazy about with this setup, but there's no spaghetti, and it's going to be very functional. There's no clipping. Those are the important things. It will be very efficient, and It will take us into the late game without really any modification except the occasional belt upgrade and just cabling up more machines to the power grid as we upgrade those belts. Okay. Screws, reinforced iron plates, modular frames. So I've definitely spent a lot more time on this iron outpost in this series than I will in the subsequent outposts. Two reasons. First, this is the first outpost, and so I'm showing like a really detailed approach to how all future outposts will be set up. And second, this is probably the most complex of any of the outposts. All future outposts will have substantially fewer products being produced. Here we've got 5 products that are being produced and collected. The copper outpost will only have 3, right? Wire, cable, plates. Concrete will have 1, which is concrete. This will probably be the most. This will be the most complex until aluminum, anyway, in Tier 7. Aluminum is now fairly complex. It is a process. Alright. So, finally, we've collected all of our products in these storage containers. And once we have more outposts, especially outposts producing or focusing on higher tier products like heavy modular frames, especially these components will be transported to the other outposts or to a central factory. I'm not sure if we'll have. I'm kind of torn right now between having outposts for each type of component. Like right now, I'm pretty sure we'll have an outpost making motors. So an outpost that makes the rotors and the stators and combines them into motors. That makes sense to me. But I think once we have the motors, those are like mid-level components, right? Motors, even heavy modular frames are like a mid-tier component. It's at the upper end of the mid-tier. We'll probably have a central factory for the very late game components. Components that like supercomputers, turbo motors, where you need a lot of mid-tier components together, like using different resources, or that contain different resources. So that's my plan right now, is to have outposts for all of the basic components and the mid-tier components. Probably everything up to motors. There'll be an outpost for Kateria making quick wire. Also probably possibly quick wire products like maybe even circuit boards in the Kateria, because we'll be using Kateria for circuit boards, high-speed connectors, AI limiters. And then we'll have an outpost for crystal, making not only silica, or I guess an outpost for quartz is more accurate, not making silica and crystal, but also probably crystal oscillators. There's not really a need for a sulfur outpost. We can have one, but I don't know if you want to construct a whole outpost just to have a really small supply of of nobelisks, maybe for batteries. I'm hoping that batteries will have more of a use than powering vehicles, once Tier 8 is unlocked. We'll see. But that pretty much wraps it up for the iron outpost. I need to put up, a few more walls, put up a ceiling, finish it off. But until we have a place for these products to go, it's pretty much finished. Next, we're going to quickly bust out the concrete outpost. We'll start with that in the next episode. That's going to be so much easier than the iron outpost. It'll be start to finish one episode, maybe with time to spare. We'll see. After that, it'll be copper. Need to find a suitable location for the copper. It's probably going to be pretty close because we've got 2 pure copper nodes. One where my cursor is right now, and then the other that we've been using for this starter base. I guess we can start deconstructing all of these machines because they have outlived their usefulness. And then once the copper's done, we've only got steel really left. And that'll be, we'll use these 3 coal nodes right here for the steel, using power shards to bump up their output. And once that's done, we're ready for the process of unlocking tiers 5 and 6. So I would say we're probably, let's allow 1 episode each per outpost. So 1 for concrete, 1 for steel, 1 for copper. Yeah. Then I say, so that's 3 episodes, and then we'll set up the automation for the space elevator parts, and while those are being automated, maybe we go and set up, like a crystal outpost and a caterium outpost. So that's the general roadmap right now. Thanks for watching. I know that the iron outpost got a little bit sticky, but I promise all future outposts will be much easier with like that to use as a blueprint. You won't be figuring stuff out on the fly. And I just ask that you subscribe if you haven't, keep smashing that like button, and stick with me as I quickly throw up more outposts in this desert. Until next time.